Hello, yeah, welcome back again. We are going to solve for the value of s from this equation with the radical exponent. And if you observe the left hand side of this equation, you notice that we are adding the same thing three times. So therefore, 7 to the power of square root of x is common. So we are going to factor out 7 to the power of square root of x. Then we open a bracket. Now we need to divide. 7 to power square root of x divided by 7 to the power of square root of x is going to be 1. Then plus, when we divide the same thing, is going to be 1. Then plus, if we divide the third one, is also going to be 1. So that when you use this 7 to the power of square root of x to open this bracket, we are going to get the left hand side back, which is going to be equal to 63 raised to the power of square root of x. The next thing we're going to do is to simplify inside this bracket. We're going to have 7 to the power of square root of x, then 1 plus 1 plus 1 is going to give us 3, which is equal to 63 raised to the power of square root of x. The next thing we're going to do, as you can see, this 3 is multiplying 7 to the power of x. So we can rewrite this as 3 then multiply by 7 to the power of square root of x, which is equal to 63 can also be written as 9 multiplied by 7. So we can rewrite this 63 as 9 multiplied by 7, then everything raised to the power of square root of x. So the next thing we're going to do in the right hand side, recall that this power is affecting both 9 and 7 because of multiplication operation. So we're going to have 3 multiplied by 7 to the power of square root of x is equal to, so they can share the power. So we have 9 raised to the power of square root of x, then multiply by 7 raised to the power of square root of x. So the next thing we're going to do is to divide both sides by 7 to the power of square root of x. So we divide the left hand side by 7 to the power of square root of x, and also the right hand side by 7 to the power of square root of x, so that this can cancel this and also this will cancel this. So we are left with 3 in the left hand side, which is equal to 9 to the power of square root of x. So the next thing we are going to do, as you can see, in the left hand side we have 3, and in the right hand side this is 9. So we can make the base to be the same. So we have 3 will be equal to 9 in index form to the base of 3 is the same as 3 to the power of 2, then all raised to the power of square root of x. So we have 3 now will be equal to 3. Then recall power property of exponent, we can multiply the two power together. We're going to have 2 root x. So the next thing we're going to do, as you can see, the base are the same. And recall, when the bases are the same, according to one of the property of exponent, the power is also the same. So therefore, we can equate the power. So remember that this 3 can also be written as 3 to the power of 1. So that when we cancel the base, the power in the left hand side will become 1, which is equal to the power in the right hand side, which is 2 root x. So the next thing we're going to do, remember we are looking for the value of x, and here we still have 2 square root of x. So we are going to square both sides of this equation in order to eliminate the square root. So we are going to have square, and also we square the right hand side, so that 1 square will become 1, which is equal to 2 multiplied by square root of x. This is multiplication, so the square is going to affect both 2 and square root of x. So 2 square is going to give us 4. Then square root of x square. Square will cancel the square root, it will remain only x. Because when we have square root of x square, this is the same as x, because square is going to cancel the square root. So now we are left with 1 equal to 4x. So we divide both sides by the coefficient of x, which is 4. So we divide the right hand side by 4 and the left hand side by 4. This 4 is going to cancel this 4. So x now will be equal to 1 over 4. So therefore, 1 over 4 is the value of x that satisfies this exponential equation. Thank you for watching, and please follow us for more videos like this. Thanks.